Welcome back, my dear students. In this 2.3 andre means the third lecture in open channel flow. Here we are going to study about channel geometry. Channel geometry means whenever your canal, say for example this is a bed slope and water is running like this, and when you see in the front view, then it will have some cross section. Randomly I am going to give you, this is a cross section. Okay, means the water is coming like this. There is a big channel like this and the water is coming, and here some parameters are there. That parameters we would like to know, and these parameters are very easy because they are all very basic. You already know in a pu, not only pu, 10th and before 10th also you might be known these all parameters. For example, the first very important parameter here is the depth. Okay, is denoted by a small h. Depth is the distance between the free surface of the fluid, this is the free surface of the liquid, to the deepest point. You need to find the deepest point here, and from there this is your depth of flow, denoted by h. Unit is meter. First one na. Then the second one very important is top width. Top width means what? See, this is your top width, means the width which is open to the atmosphere. Above this one, what is there? Atmosphere is there. This width is in contact with the atmosphere, that is called as top width and denoted by capital T. And the third very important, very important is wetted perimeter. Wetted perimeter denoted by capital P. Wetted perimeter means the perimeter which is wet by this fluid. For example, this. Okay, see, this perimeter is in contact with the fluid. Then when it water is moving like this, then there will be a resistance offered by that wetted perimeter to the moving fluid, that is the flowing fluid. Therefore this is a wetted perimeter, very important parameter. And the fourth one is area. Cross sectional area of the flow, means the complete cross sectional area of this water. This is a area. Okay, denoted by A. And here I am going to introduce you two more parameters, a new parameters. The first one is a hydraulic mean radius. That is what? Hydraulic mean radius, denoted by capital R. This we are calling it as the ratio of wetted area to the wetted perimeter. If I put a area here and perimeter here, then the answer what we get is called as hydraulic mean radius. And the sixth one, important parameter is hydraulic mean depth. Hydraulic mean depth and denoted by capital D. Capital D. This is the ratio of wetted area to the top width. Wetted area to the top width. These six parameters are very important. And you know how to determine this top width, that will be visible to you. And wetted perimeter by knowing the geometry, area, and if you know A and P and T, then you can get hydraulic mean radius, hydraulic mean depth easily. We will go one by one. Okay, in open channel flow you can have shapes of the cross section, like a rectangle, trapezoidal, triangular, circular, egg shape, half egg shape, or combination of triangle and semicircle. Like that you can have many cross sectional area, that shapes. But usually in common there are four that cross sectional shapes. The first one is a rectangle, second trapezoidal, third one is a triangular and circular. These four are very important. We are going to discuss one by one. Look at here, this is your rectangular. This is your rectangular. Then if it is a rectangular, then water surface is here, and this I will call it as a breadth of the channel. I will call it as a bottom width, and this is the height of the water, that is a h. Okay, now then define the first parameter. What is the first parameter? The first parameter is top width. Hmm. Now, what is the top width here? T. T is equal to B, right? Top width and bottom width are same in rectangle. Then after that we will be having perimeter, wetted perimeter. Wetted perimeter denoted by capital P, and here how much that length is wetted here? This is wet and this is wet and this is also wet. Therefore, we have B plus 2H is a wetted perimeter. Understood? Then what is the wetted area? The area is the complete area. That area is, therefore B into H is the area, right? And after getting these all, then you can write hydraulic mean radius, that is A by P is nothing but BH divided by B plus 2H. This is your hydraulic mean radius. Then what is the hydraulic mean depth? Hydraulic mean depth is BH divided by top width, that is your area by top width. Then BH divided by top width is what? Top width is B only, therefore B cancel. This is your D, sorry, this is your H. Hydraulic mean depth for rectangle is the depth. Understood? Now after that what? We will go to next section, that is your trapezoidal section. In this trapezoidal section, usually we will be having 1 in n. This is the denotation 1 and n. N means what? That number, whatever it is. For example, if it is a 1 in 2, 1 in 2, then I can say 1 meter wide vertical and 2 meter horizontal. Then if I join this one, then I will get a side slope. This is the meaning of 1 in n. You can represent the side slope in 1 in n, or you can represent the side slope by having a theta also. This is the theta, right? But we will consider 1 in n for our further procedure, that what calculations. We will not consider theta and go ahead. We will consider 1 in n and go ahead. Okay, if in examination if theta is given, then what to do? For example, if, look at here, if this is the slope and theta is given here, this theta, say for example 30 degrees given, then by knowing this 30 degree, you need to convert 1 in n. Write it 1 in n. See, this 1 in n and this 30. I am just combining them. Then here, if I define tan 30, then what I will get? I will get opposite by adjacent. Then n is equal to 1 by tan 30. You got n meaning. When you get the meaning of n, then you can just substitute that here and go ahead with our procedure. As I told that there are two ways to determine the trapezoidal sectional parameters, by using n and by using a theta. I prefer by using n. If theta is given, then you need to convert that into n and go ahead, right? Now let us consider this is a 1 and this is a n. Then I have to make this one. Then this is a bottom width B, then this is also bottom width B between these two. Then what is this, or what is this? Look at here. If it is 1 meter and horizontal is n meter, if it is a h meter, then horizontal is nh meter by using similar triangle. Then this is also nh, right? Then look at this triangle. In this triangle, if I write it separately, then what I am getting here, this is a h and this is a nh. Then what is this side slope? This I will call it as a slope, side slope. That you can write it as side slope square is equal to h square plus n square h square. Whose theorem it is? Pythagoras theorem. H square is taken common, 1 plus n square. Then SL is equal to square root of h square plus 1 plus n square. Therefore, h into square root of 1 plus n square is your side slope. Then may I write it here? Yes. This is h into square root of 1 plus n square. Right? Now I will write all the parameters. The first parameter is top width. What is your top width here? B plus 2nh. Am I right? Yes. Then after that we will calculate perimeter, wetted perimeter capital P. That is your B plus 2h root 1 plus n square. Right? This is a wetted and this perimeter is wet, this perimeter is wet. Therefore B plus that side, this side, 2h root of 1 plus n square. Then we will calculate area. What is this area? Area is the entire area. How to calculate the entire area? Top width plus bottom width divided by 2 into h. That is top width plus bottom width divided by 2 into height. This is a general area formula for trapezoidal. Now top width is what? B plus 2nh. Bottom width is B divided by 2 into h. Therefore area is equal to B plus B, 2B, 2nh, 2 to cancel. Then B plus nh into h. This is your area. Over. Once you get the area and perimeter and top width, then the rest is very easy. That is your hydraulic mean radius, then that is area divided by perimeter. That is nothing but B plus nh into h divided by perimeter. That is your B plus 2h square root of 1 plus n square. Okay, then hydraulic mean depth, that is your area divided by top width. Area is B plus nh into h divided by top width is B plus 2nh. Right? This is a characteristics of trapezoidal section. Right? Next we will go to triangular section. Here also, as I said, this will be denoted by 1 in n. If it is given in terms of theta, then we will convert it 1 in n. That is already told. Then what is this side slope here? The same thing, 1 plus n square, h into 1 plus root of 1 plus n square. This is the side width. Then if I make a mark here, then this is your height and this is your n into h, n into h. Just compare the previous and here this one and triangular. If you compare, this portion is gone, then this side and this side will come and you will get a triangle. Okay, the same thing. Then what is your top width? Top width will be 2 times nh over. Then what is your perimeter? Perimeter is 2h square root of 1 plus n square. This is also over. Then what is your area? Area is half into top width into height. Correct? Actually we will call half into base into height, but it is an inverted triangle, therefore like this. Then half into top width is 2nh into h, therefore 2 to cancel, nh square is your area. Okay, after this one it is very easy to calculate area. Hydraulic mean radius is a by p. Then substitute the corresponding values here. Then what is your hydraulic mean depth? Hydraulic mean depth is a by t. Right up. Now we'll go to circular section. If this is a circular section, then the water, if it is moving this much of water, then I will call this as a water level, and let us mark this one this way. Then what is this distance? This is a O A and this is a B. OAB. OA is a radius and OB is also radius. I will call it as a small r. Why? Because capital R is already used for hydraulic mean radius, therefore small r. Right? Then this much of water is flowing here. And what is the definition of H? H is the free surface of the fluid to the lowest point. Therefore I will call this as a H. Okay. Then what is your top width? This top width is something like this. Okay, this and this is your top width, right? Then if I call this as a theta, then I will call it as a O B, and you can call C. Okay, then OBC triangle you need to take, then you write a top width half of this one, x we will call, then define sine theta. What is this? Opposite divided by hypotenuse. Hypotenuse is OB and opposite is x. OB is nothing but r, therefore x is equal to r sine theta. But this x and this x, two x's are there, then you will get the top width, therefore t is equal to 2r sine theta. Very important, right? Then what is your h? Can you express this h in terms of radius? Yes, we can express. Now ABC D we will call, this is your C. Then you look at here, OD. What is your h? H is equal to OD minus OC. Okay now, OD minus OC. Then h is equal to OD means radius minus what is OC. Then come here again in this triangle, if you define cos theta, cos theta is equal to adjacent OC divided by hypotenuse OB. Therefore OC is equal to OB cos theta is nothing but OB is what? R. R cos theta, you got it. Then you come here, this is your R cos theta. Then take R common, and H is equal to R into 1 minus cos theta. This is your H expressed in terms of R and theta. Two are there. Then what is your perimeter? Perimeter, look at here. If you have a arc like this and this is a theta, then this is a radius, then you will call it as a r theta, right? The same way we have here theta, and this is theta, 2 theta, 2 theta, and radius is r, therefore r into 2 theta. Okay, therefore P I will write it as 2r theta is my perimeter. Okay, then what is area? This is the entire area of flow. Okay, for this one you have to remember this equation, r square into theta minus sine 2 theta by 2. Okay, you remember this as it is, because it is derived equation. That derivation takes a lot of time and not required for us. Okay, this is your area, right? Now after this one, what you can calculate? You can calculate that was hydraulic mean radius, that is area divided by perimeter. Here is the area, here is the perimeter. After calculating, put that value here, put that value here. This is your hydraulic mean radius. Then hydraulic mean depth, that is your area divided by top width. Then this is your area and this is your top width. Substitute that and you will get this, right? Now if a water is flowing this much, if a water is flowing this much and you have only vacancy here, then we will make a center, then we will mark this, mark this. In this case you read theta this much. If you read theta this much, then all the values whatever that is explained in this slide will holds good. Okay, no need to discuss anything, just theta you need to read in this way. Over. Okay, one very important thing I am going to tell you here. I am going to consider few problems here. See, the rectangular fundamental is very easy. If you know, if you know B is given 5 meter, then H is given 2 meter, then you can calculate top width, perimeter, then area, then hydraulic mean radius, hydraulic mean depth. Direct substitution, H is equal to 2 and B is equal to 5 over. Therefore nothing to worry about the rectangle, nothing to worry about trapezoidal. That twist I already told you, that if it is given 1 in n, then that is good. Then you will substitute wherever that n is there in our equation, that you will substitute and go ahead. Okay, take, if you want you can take one problem. That one problem is, you take 1 in 2. 1 into, then bottom width is a 3 meter, then height is a 2 meter. Okay, solve this problem. Very easy. And this is your B, this is your H, and this is your 1 in N. This much only is required. Substitute in the given equation and you will get it. Second twist I am going to do in the trapezoidal channel. Look at here. Here it is given 2 by 3. See, 2 by 3 it is given. But I taught you that it should be 1 in N. Then here 2 in 3 is there. That is wrong. Therefore, what we need to do, if it is like this, 2 and 3 is written, then you need to make it like this. This make it 1 and this make it 3 by 2. Means divide both of them with the 2. Then 2 by 2 is a 1 and 3 by 2 is a, then you got, this is 1 in 1.5. Okay, then this is nothing but what, the slope is 1 in 1.5, then N is equal to 1.5, then rest all the things are same. You can go ahead. Okay, then the third one is if your theta is given, okay, theta 30 degrees is given, then N is equal to 1 by tan 30. 1 by tan 30. Go ahead. Right up. This is how you will solve the problems. I hope you understand it because it is very easy. And triangle, the same concept is there. Here bottom width is not there, but their bottom width was there. Now coming to circular is a very interesting. I am going to give you one problem. Let us consider this much of water is flowing. Okay, and let us consider this angle is given 30 degree. Okay, 30 degrees given. Okay. Now what is theta is equal to 30 degree. Let us give radius is a 2 meter. Then what is the radius equal to 2 meter. Okay, then what is the top width is equal to 2r sine theta, that is nothing but 2 into sine 30 degree. Over. Easy? Easy. You can calculate. I don't calculate. Now, coming to uh, parameter, perimeter. Perimeter is what? 2r theta. Then 2 into, what is r? R is 2. And what is theta? Theta is 30 degree. Over? No. This is very interesting. This is not like this. Here theta is not with its parents. Its parents is sin theta, cos theta, tan theta, cot theta. They are all their parents. But theta is not there with the parents. Therefore, we need to beat that theta. Now see 30 degrees there. We need to beat it and we need to make it a small. Okay, how? By multiplying 180, pi by 180. Means we need to convert this theta in terms of radians, then we need to say perimeter. Directly 2r theta, you cannot, that is the wrong one. Then you got a perimeter, whatever the value you will get it, that is your perimeter. Okay, now come to here. Area formula is r square into theta minus sine 2 theta divided by 2. Okay, now I will substitute 2 square into 30 degree minus sine 2 into 30 degree divided by 2. If I write like this, wrong. Very interesting. Again it is wrong. Why? Because see, this theta is there now. This person, he is alone here, but this theta is with parents. Therefore I have to consider 2 square into this 30, that is individual, that is a single. Therefore we need to beat that one, that is not with parents. Convert this into radians. Minus sine 2 into 30. Don't convert this one. If you beat, your sine will come and beat you. That's why 30 as it is 30. 30 into 2, 60. Sine 60 divided by 2. This will be your area. Answer whatever you get here. Okay, now this is very important when it is in a circular section. The handling the theta is very important. Okay, thank you very much. This much is enough for this class, and today and tomorrow onwards we will see some advanced topics. Thank you.